general updates, but oh yeah, we should record. So good evening, everybody. Welcome to another episode of Eclipse Megamovie. We are the agenda today. We'll just give you some updates on the Megamovie work, and then we're going to have some wonderful sharing from all of you of some of your auroral photographs. And then Dr. Juan Carlos Martinez Oliveros will talk about some of the research he's doing with our work, with this project. So I'll start just by, and Juan will go into more detail, I imagine, on some of this, but we've been busy looking at data, and we now have several copies of the data in different locations. That's exciting in itself. It's a huge data set, so it takes actually having a hard drive and carrying it around. We have a plan for sharing out the data, but we have to implement that plan. It will be hosted on a NASA Goddard server, right, Juan? With Jack Ireland.
Yeah, the SDAC server.
Yes, which stands for Solar Data
I don't know.
Analyst Center. I learned this recently, last week, in fact. The SDAC. Did I get it right? Solar Data Analyst Center. Analysis Center, actually. Sorry, analysis. But we have to basically take all the metadata you gave us in the spreadsheet and make sure that the timing and the latitude and longitudes are correct, and anything else we need for the metadata for a FITS file. So FITS file is a way that astronomers communicate with one another about their data and their images, and it's like a fancy EXIF. You can think of it that way. An accurate, fancy EXIF. And then with that, we can, then anybody can use your data for research. And I presume, I think actually some of it will we're going to use it for research. We are working on that, as Juan will tell you. But I expect other people in the heliophysics world will as well. So that's going to be exciting for everyone, NASA included. They keep asking, is the data out yet? Like, the data's huge, and no, it's not out yet. And it's not in my proposal that it will be out yet either. So we knew it would take a while to analyze. But we do have lots of code we're testing out, and we're working on rotations, and so we're going to Juan and I will be at the American Geophysical Union conference, which is our scientific conference where we go and present research. And we'll be there in 2 weeks, I guess. 3 weeks. 3 weeks. Did I frighten you? 3 weeks. And we have a student who will be presenting on her work over the summer, which we talked about last episode. Eclipse Megamovie episode. And then we also, so getting the data ready and up on a server, and also getting our Kaggle competition finished and closed out. We've got someone snuck into the lead over our last leader in terms of categorization accuracy for categorizing eclipse total eclipse images versus other partial eclipse images, and diamond rings and Bailey beads and flats and darks. So that will help us having everything labeled in our analysis. So those are some of the things. We're also working on getting all your names up on our website. I thought that would happen faster, but you all helped in so many different ways. We wanted to take the time and figure out in what ways you helped. So we're organizing it, your names and the ways that you helped. So that's taken us a little bit of time as well. And there are only a few of us working on this project. So we're trying to do all of it and more. And then Hannah's been working on all our communications, and NASA wants to make another movie, and show it at the American Geophysical Union. And in that video, I think they're going to talk to press about that. Some of your data's in there that you, and so Hannah's been making sure the NASA folks get what they need to brag about all of your great work. So I think that's it. I think that's what we've been working on. And much more. Juan will go into great detail about more. Hannah, anything else I should say?
Nothing else I can think of. Covered Kaggle, covered NASA using images, covered data set updates.
Okay. So I think it's next we're doing share time. Okay. Hannah, you want to lead this?
Sure, I can do this part. So I have on the right side of my screen a list of names. It looks like it is not in alphabetical order. So I'm going to go down this list just to keep it kind of orderly. At the top of the list, I see Diane. Diane, are you ready to share your screen?
Yes, I can. I'm ready to try to figure out how to share my screen.
All right, you
I
should be
believe
able
there's a
to.
share button down here. Let me try. And I don't think I need that.
We are going to try to keep it as close to 5 minutes as possible, just in the interest of time. And then if we hit 5:40 or so, we're gonna stop and let Juan Carlos give his talk. And then anyone that's left, if we haven't gotten to you, we will make sure you get to go next time. We will
Okay,
prioritize you.
I'm hitting the share button at the bottom and I'm not getting my screen. I can see the bottom of it under here. Do I have to go down and do something like this?
There is another step. Yeah, there should be like a pop-up window where you click on it.
Yeah, and you click on your screen or it says desktop 1 or 2 or something like that.
Now I'm trying to get back to this one that I just minimized up here. Okay, it says share, there's a green share at the bottom.
Uh-huh.
When I hit that though, I just get, I don't know if you're seeing this thing, I get oh wait, there's another share, aha. There we go.
Aha. There's your screen.
Okay, yeah, I don't really know if the things I'm interested in have any meaning for you guys. But I was going to try and pull up, and I've got my folder hidden under this thing. I can move that. There we go. I just pulled up a folder with a couple of things here. My obviously favorite Eclipse image, I'll just throw it up first, and then
Wow.
we can, no, let me move this. Can I minimize that or move it over? Here we go. This is obviously the 2017, and I'm just tossing it out for the heck of it. But we went to the middle of Nebraska to shoot this, and I was able to composite an HDR of the corona. I'm not delighted with the processing in it because the Canon camera I shot it with, if I stretch it far enough, you see some um, uh, vertical light and dark lines through here. I don't know if I can do any better or not. I did throw in the Earthshine shot from before it went into Eclipse. And then I shot the Starfield. I actually shot it 6 months ahead, but it wasn't very good. I shot it later when that was in the dark. That part of the sky was dark, so I could pick up the stars nicely. And I shot that with an astro camera and processed in PixInsight. And I think this is just a ping. I can't really zoom in on it. I could do that on a different screen, but just to show you what I am interested in doing, that kind of thing.
Yeah.
But my latest interest has been in some Milky Way shots. I'm not in a geographic location where it's very easy to shoot good Milky Ways, but I did a couple of workshops a while back, and I got a Milky Way that is, let me try to find the right one. Well, let's just start with this one. This is just a zooming in. This is with PixInsight. I hate the way my Milky Ways normally come out. No, I'm sorry, this is the raw file. This is zoomed in to 100% on my screen. This is the Lagoon and Trifid area. And there's so much noise and the stars are crummy looking. And so I was trying to find a way to get better stars. And there's a thing that, oh, and here's a 14 millimeter. The lens is just horrible. This is supposedly a good lens, but you get all these coma and astigmatism things going on in the corners, in addition to the noise. It's just very frustrating, even though I'm not going to print a full-sized image. If I go to Starry Landscape Stacker, we're back to the middle here, that lets me sort of get rid of some of the noise. Allegedly, that's what it's about. But it doesn't really make the stars nice. What I like for nice stars is what I can do with PixInsight. So I pulled a bunch of Milky Way shots into PixInsight just for the heck of it and stacked them. It was only 8, I think. But I was able to get nice pinpoint stars and a little bit of nebulosity here in Lagoon and Trifid. And the corners have these lovely round stars. This is just a screenshot so I could pull it up quickly without stumbling around. But even the corners are good, because what I did was I stacked in PixInsight and took the integrated file, just like I would a normal Astro thing. And there's a wonderful tool in PixInsight called Blur Exterminator. And it is just a miracle for stars. It took all those funky stars in the corner and made them pretty little round stars. And
Cool.
I do have a problem still learning how to, because that's an unstretched image. I have to stretch it to get the stars back in their normal, how you would see them, bright enough. And when I stretch, I'm having trouble getting the sizes the way I want. But that's a matter of just some experience and learning. So that's just
Awesome.
my thing for recently, that I figured out a way to have better stars in
Yeah,
my.
I think that is time, Diane.
Yeah.
That's your 5 minutes, but wow, do
Okay.
you fill it up?
Okay.
Thank you. And, you know, we can do this thing more often. Absolutely. Give you guys a chance to share. So next I see Gary.
Those are beautiful. Absolutely stunning.
Gary, are you sharing today?
Okay, yeah, I have a one shot here.
You'll be done at 5:21, according to my
I
screen.
don't think it'll take that long. Let's see. Okay, here we go. And then share. You seeing this at all?
Wow, look at those colors.
It's my Aurora picture. This was done on the night of October the 10th and the morning of the 11th. You can hear me okay?
Mhm.
Okay, good. I just wanted to make sure. I was heading out of town to get to a darker location. We're out in the middle of kind of nowhere here in Clarion, Pennsylvania, about halfway between Pittsburgh and Erie. But we still got town lights with the university here and everything. There's quite a bit of light, so I wanted to get out in the country. So I had a couple places I was looking at. The first one was a church parking lot, and they had security lights all over the place. So I was heading out of town. I wanted to mention this too. I was heading out of town, and I got a phone call from my sister, and she said, "Can you tell me a good dark place to go look at the aurora from?" And she was out somewhere else on the other side of town, and I said, "Well, you're going to be looking toward the north, and that's where the mall and all the lights are. So just come on over the other side of town and go with me, because that's what I'm doing."
Gary, suddenly you got very quiet.
I don't know why. I'm trying to think of what I could do if I didn't
Maybe just
change
closer to
anything.
your microphone.
Yeah, well, I haven't changed my distance from it.
Oh,
There we
yep,
go.
then you got louder.
Okay. So anyways, we headed out of town, and the church parking lot had all sorts of security lights around us. So I said, well, we got to go find someplace else. So I found a road that looked like it went through the middle of a couple of fields, so we'd have clear view into the north. And we went out there, and I set up my tripod with, yeah, I put my cell phone on there. No, I can't remember whether I had my camera or my cell phone. Anyways, it was too faint. The same old story. It was too faint to see with the naked eye, but we were getting some pictures of it, and she had her iPhone, and she was getting some pretty nice pictures. So I kept fooling around with my settings, trying to get nice pictures like she was getting, and finally I got this one, and we were out until after midnight, and we are getting ready to pack up and go home when all of a sudden we got these movements of within the green area. Can you see my cursor?
Mhm.
Yeah.
Yep.
Okay. These were actually waves of light going up from the horizon.
And you could see them with the naked eye?
We could yeah, we could see them with the naked eye,
Wow.
but of course, to get a really good look at them, we needed help, but it was too faint to pick up on a movie, shooting
Mhm.
a movie with it. So this is only a little taste of what we actually saw. It was so incredible, our mouths were dropping open seeing this, just looking at naked eye. And
Very cool.
this picture's enhanced to bring out the colors. I increased the color saturation to bring it out a little bit better. But
Mhm.
all this what do you call it? All this stuff down here near the horizon is
Yeah.
actually moving up from the horizon.
Wow.
Yes.
And,
That is
and
so cool.
yeah,
Oh,
I was happy to get this picture. Somebody have a question? I thought I might have heard somebody. This is my comet picture taken from my front yard looking across the street.
Wow.
And this came out pretty good. This was enhanced a bit too, to bring out the tail a little bit better.
Mhm.
And but I was glad I got one. This is a lot better than Neowise, my picture of Neowise. So it was happy. It made me happy.
Yeah.
But,
Makes me happy to see it too. Thank you for
yeah.
sharing.
Mm-hmm.
Perfect timing. Um, and the person asking a question that you heard was actually Laura, who can't help but talk about Aurora because it's what she loves very much.
Mm-hmm. I've
And
been
she wanted
waiting
to
a
answer
long
your
time.
question.
Yeah. But I've been waiting a long time to see that aurora,
Mhm.
and teaching about it a long time. When I was younger, my dad said he got us kids all out of bed, and we ran back to the backyard and watched an aurora. And that was when, I don't know, 5, 6 years old, something like that. And I've been waiting
Wow.
all that time to get another good look at an aurora. And I'm still
Thank
waiting
you.
to get a good look at an aurora.
Mhm.
I'm on a mail list to alert me to when the
More
geomagnetic
storms.
activity is increasing. Yeah.
Mhm. Awesome. All right. Next on my list, Basil, are you sharing tonight? No pressure.
Yes, yeah, I just do. Unmute my microphone. I have some auroral photographs that I could share.
Sure.
Um,
Whatever strikes your fancy. You've got 5 minutes.
okay, so let me see this. Let me share my screen. Mm, Go share. Okay.
Ooh, more Aurora. Yes.
But this was May earlier in, but it really was much more spectacular than that image. Our dog had died that day, so it wasn't
Oh.
a great mood. Yeah, so I had the wrong exposures, the wrong f-stop, so and I actually don't know the details of what I took, but it was quite spectacular. But The ones I do want to share that are even better are the ones from October, the 10th and 11th. I mean, that's another screen. Hold on.
What do I have to do to see the screen that's being shared?
Up at the top of your Zoom, it's not being shared right now, but as soon as it is,
Yeah.
there's two like options at the very top bar of your Zoom screen. There's meeting and then there's Basil's screen. Make sure you're clicked on Basil's screen.
I'm not seeing those at all.
Hmm.
Well, maybe it's because it's not being shared yet.
It
Well,
is
it could
being
be you need to
shared.
update your Zoom.
Or you have full screen. If you're in full screen, you have to go to the top right and there's a little box that says view. And then there's a bunch of different views.
That is also correct.
Speaker gallery, multi-speaker.
Speaker
meeting.
gallery should get you.
I
You-
tried that, them seeing all the participants.
Okay, if you so you are in full screen, can you minimize, or not minimize, but click on the green little
Yeah.
button?
Shield.
Shield, yeah, now you should be able to see on the top meeting versus Basil's screen of the Zoom window itself.
Unless Zoom is not updated.
I might have to go settings.
But can everybody else see what I'm sharing, by the way, at the
We
moment?
can. Yeah.
Yeah, go
Yes.
ahead. I don't want to hold things up.
Okay.
Thanks,
So
Gary.
Rich, somebody's waiting, is that right?
I got
Rich?
it. Don't worry about it.
Okay, all right. So this was October 10th, 11th. This was early in the evening. This was not visible to the naked eye. This was a fisheye lens. It's 180 degrees almost, but except my house is here, the roof. And so it initially started with this SAR arc, which got more intense, and then and the aurora was down here. But then as the night went on, it was mainly this Sarak, is that, I hope that's how you say it.
Mhm.
That was intense. And then later, like midnight or so, the auroras came up and became more and more intense. And these are photographs taken every five minutes or so. And it peaked to around 2, 3 o'clock in the morning. I can't remember exactly.
Wow.
And then it died down. It was quite a night actually. I've seen aurora a few times. I grew up in New Zealand, so I first saw aurora australis back in 1980s. But this was one of the best I've seen. Although maybe my eyes are not as sensitive as they were when I was younger. I didn't quite see colors, but it was quite a night.
Yeah. My understanding is these aurora that you would have seen as far south as we did with the storms are harder to see with the naked eye.
Okay,
But aurora that you would have seen maybe
okay.
elsewhere further north would have been
I,
all
I was
clearer.
I'm in Southern Oregon, like Ashland, Oregon, so I'm just
Cool.
like 15 miles from the California border.
Cool.
Thank you.
Yeah. Thank you for sharing.
By the way, everything was
Um,
showing on my second monitor.
Oh, that explains it.
Aha.
Next on my list, I see Chris. It is time for your debut.
Well, I'm still rendering the movie. I have 12 minutes left, but that's okay.
Oh, we can get
Oh,
to
no,
you a
no,
little
I've
later
got
if you
other
want.
stuff
Okay.
I can show. I can link to it. I have some other stuff I was doing. So I'm putting this in the chat right now. So this video, and you can look at this later. It doesn't have to be right now because, well, they can just be later. The first video is actually a difference between city lights and country lights because yeah, it's not going to come out that great. But I did 2-minute exposures for my backyard in the city, and then I did 30-second exposures from our dark sky site. And what I did is a time lapse, or not really time lapse, a kind of a blend between them, so you can see just how much detail you're pulling out between the 2 minutes in cities and 30 seconds in dark sky sites. So it's like you can do so much more from a dark sky site than you ever can from a city. And you just get so much detail so much faster. This is all with an 11-inch Hyperstar, 11-inch Schmidt Cassegrain with a Hyperstar. So it takes it from an F10 to an F1.9. So it's super
Wow.
fast. And just in 30 seconds, I was able to get so much more detail than I could. And this is without a filter. This is just naked,
Huh.
naked sensor with a ASI 2600. So yeah, it's really, really straightforward. This is a time lapse I did. The next link is it's a time lapse I did really fast. I did not intend to do a time lapse of the aurora, but it ended up being a time lapse of the aurora. But I'll leave that on. Let me do this real fast. Where is it? Screen one. There we go. So just really fast. We don't have great skies here for the comet. It was low in the sky, and in the city it was pretty bright. But I did manage to do some processing. You could see the split in the tails. That was actually pretty cool. I didn't think we could see it, but nonetheless, we actually could. That was pretty neat. I
Awesome.
also did a, see if this will come up. Will this come up? No, but that's okay. I can just drop it into here. There we go. So this is at the lake. We were shooting toward the west across Benbrook Lake, and you can see the tail ends somewhere up in here. So it was really, really extensive. This was with a 75mm lens. Uh, so it was just a long, long tail. And that
Yeah.
right there, that's someone just shining a light up into the sky. It was annoying us every single day of the week that we were out there.
Wow.
We went out there. It was quite nice. Um, this one I actually managed to get. I don't know if you can see, but this is the anti-tail right here. I get a little bit closer. You can see the anti-tail.
I have never even heard of an anti-tail.
So what happens is, as it was swinging back around, this is the dust that was already dumped, and then the tail swung past it. So the anti-tail
Ah,
looks like it's pointing toward the sun. Really, we're looking through the dust that's coming out towards us, essentially,
cool.
or what's going out in the other direction. So it's called an
Uh-huh.
anti-tail because it points away from the regular tail, but it is still pointing away from the sun. It's just our perspective. And I was really impressed. I was able to capture that.
I'm
Um,
really impressed too.
yeah, that was pretty cool. This dark spot in the middle, it's my lens. I have a set of cinema lenses that we use for my cousin's filming, and they're nice prime lenses. They're nice and open. I think this is like a T 2.1. So cinema lenses use T stops. Photographic lenses use f stops. They're kind of the same, except the t-stop is calculated. So every lens at a T 2.8 lets in the exact same amount of light. Doesn't matter how much aperture, doesn't matter how big it is, what the focal length is, it's the exact same amount of light.
Hmm.
So it's because you want the film to look identical.
I see.
So
Mm-hmm.
this is something I took, I think this is the first night that we could see it. And you can see that there's a split in the tail. There's the main part here, and there's a secondary coming out here. I think this is the ion tail, not 100% positive, but it just wasn't that great of seeing. But I still managed to get something out of it. And with stacking and processing, it came out pretty good. So I'm
Yeah.
still doing the video. It's still another less than 10 minutes until it's done processing. It's the Eclipse video. So just
If you share it with me, Chris, I'll send it
yeah,
out to the listserv
yeah.
and put it on the
I'll put it in the
Discord.
chat.
Okay.
So this is the elephant trunk. This I did from my backyard. We had about 3 weeks of fantastic weather. It was warm, but it was still air. It was dry. It was no rain. So I had my scope and my mount outside the entire time. It was fantastic. This is why I want an observatory. So all I have to do is go outside, plug in a laptop, warm everything up, go back inside and control everything from my office. So this is the result of, I think, 4 nights, about total, I think somewhere about, I want to say 9 to 10 hours of data from the city to get the elephant trunk. So
Wow.
yeah, it's I'm pretty happy with the way this one came out. It was like that's kind of what it looks like with basic processing, just
Uh-huh.
out of PixInsight, and then oops, there we go. So with more processing, I could do stuff like this as well.
I like
And
the pinks and purples, not gonna lie.
oh, that one, yeah, but the dark nebula don't look
Mhm.
as good. So that's why I brought it
Definitely.
back to here, and you can see a little bit more detail in it. But I'm pretty happy with the way the elephant trunk came out here. It's
Yeah.
I managed to pull out a whole lot of detail. Again, this is the 11-inch SCT with the Hyperstar on it.
Hmm.
The
Are you on our
Hyperstar,
Discord server, Chris?
sorry?
Are you in our Discord server?
Oh, I never
If you
have
use Discord?
that kind of stuff.
Okay, no worries.
I was working till 2 o'clock in the morning yesterday, and I've got
For
another one
sure.
tonight today. So yeah,
Oh,
I
that's
don't.
me being selfish because I just want to see more pictures.
Oh, I've got tons. I just haven't had any time to process it. And actually, what I was trying to do with this one is, and I'll do it for for our YouTube channel, is do a show the processing steps, show what a raw
Mm,
image looks like, and then from the raw image, do the stacked image, process the stacked image, and then once I bring it into Photoshop and do the colors and everything else to get it as pretty as I like it.
awesome.
Just to show that kind of thing. I'll probably also end up doing like a live video of me doing processing just so people can see what it takes. But yeah,
Cool.
I guess, yeah, that's it
Thanks
for
for
me. I've got
sharing.
another 7 minutes till this finishes rendering.
All right.
Stop share. There we go.
Thank you, Chris. Next, Dennis, are you sharing tonight? No pressure, just going down the list. Okay, thanks for letting me know. Jennifer, sharing tonight? Again, no pressure.
I can. I have a few from the Aurora in May.
Go for it. You've got your 5 minutes. You're a co-host now, so you should be able to share. Yes, we will definitely do this again. Can we do Jennifer and then Steven? Cool. Yeah, we'll do Jennifer and then Steven will be our last one. And I will write down everybody who didn't share and make sure you go first next month. I did not expect this to be so popular. Thank you, guys.
So sorry, trying to get this back to the right size.
No, you're doing great.
Jumped. Okay.
Bye.
Okay, so can you see my screen? It says that I'm sharing.
Yes.
Okay. So I have several pictures from the Aurora because I started out in my front yard. Just kind of hearing throughout the day. I think I started hearing on the Thursday before May 10th, and May 10th was a Friday, that we were going to be able to likely see Aurora where we are. And I have been following a group for Auroras in Washington State. For reference, I live in the South Puget Sound in a place called Gig Harbor. And so I started hearing on Thursday that we were going to potentially really be able to see the Aurora, and I had been following this group, and the group started getting very excited about the potential. And then on Friday, it was kind of a long day at work, and so I got outside kind of not expecting much because they're pretty elusive, and we'll hear that we see them this far south, and then it just kind of peters out and you don't end up seeing anything. When we started, I was looking at sections kind of over near the trees over here and saying, oh, I think I might see a little bit of color. And then as it got darker, you could start to see colors in more parts of the sky. And eventually it got to this burst that happened right over our front yard. And so many of the pictures I have are very nearly vertical, straight up, like as far back as my tripod could tilt. Most of them are in the 15-second range that I'm showing here tonight. And I spend a long time just trying different wavelengths to try and, or I'm sorry, trying different exposure lengths to try and grab as much of the color as I could. So this was sort of just as the burst was starting to happen. And I was like running in between pictures here. I was running back inside and hauling my kids away from their computers to come outside and take a look at this. And
Wow.
so the colors just got really amazing. And then the burst started to come into more focus. And I'll tell you too that several of these are corrected for a little bit of contrast, but not much for the color at all. It really, it wasn't this intense to the naked eye, but all of these colors were visible. It was pretty wonderful.
I love all the purples.
Right?
I'm biased. I love purple, but I mean, wow.
And then kind of when the kids got a bit tired of looking at it and had kind of moved back inside, my husband and I went down to a city park that is about 2 miles from the house. And this is the view just across. It's called Des Mornay's Sand Spit. And you could walk out towards the edge of the sand spit, and we were looking straight across at the Key Peninsula. If you have a map open, the Key Peninsula, which is kind of across the water right here from Gig Harbor, and the moon was beautiful. And again, these colors were much fainter to the naked eye, of course, because these are like 13-second exposures, but the color was everywhere, and
You
it
can see it in the
probably,
reflection too.
yes,
Sorry to interrupt.
the reflections get really excellent here. And the angle that we were looking at was very close to 180 degrees, and you could see them all the way across. This is looking obviously right at the setting moon.
Mhm. You got about 30 seconds, Jennifer.
Okay. So I will say that it is very hard to stand still for 13 seconds if you're trying to get yourself in the picture.
Mhm.
And some of these haven't been processed much at all. There are a couple that have good reflections off the water.
Ooh.
And then I think, so here's another one. And the last one I'll share is that I went out, what was the date? On the 22nd, and caught what may have been the last glimpse from this area of the comet. I haven't been able to get the time together to be able to stack the images. So I spent about an hour and a half and tried to get as many sets as I could so that I could stack them effectively. And this is when I just adjusted the contrast a little bit, and that's all that I've done to this. So hopefully I will have something that looks clearer when I get something stacked. But this was like the one night that I was able to, that there was no overcast, that we weren't socked in with clouds, and I was able to get some of the comet pictures. And so I was excited about that.
Way cool. Thank you, Jennifer, for sharing. It'll be exciting too if we do share out nights like this in the future. If people come back with photos that they've finished processing, I would really love to see those. Like, compared to the ones that you show us that doesn't have much processing, you come back after processing. That would be really cool. Okay.
How do you get on the list?
List of people to share?
Yeah.
Well, I thought we were going to have time for everybody to share, but unfortunately we ran out of time. So you're going to be on the list to go very first. Well, you're going to be one of many to go first next week or next month. But I'll make sure if you want to put your name in the chat for me, if you wanted to share tonight, but you didn't get a chance to, I will make sure. I should have called on Kaz earlier because it was his idea. My goodness. You'll go first, Kaz, next month. Sorry about that. Yes, but I mean, next month, if we don't have a speaker, we can probably just do all sharing. So We'll work it out. Laura and I will work it out. Next is Steven. He's our last one for tonight. And then the great Juan Carlos is going to talk to us about the work he's been doing. All right, Steven, you should be able to share now.
Okay, can you hear me?
I can hear you great.
Fantastic. Can you see that? No.
Almost?
There we go.
Yes, I can see that.
Yeah. So my story was that I was going to go out and look for the comet about an hour after sunset, and I stepped out the front door, and there was a blazing red aurora overhead, directly overhead, and it looked like it was emanating out of the north. I could see like rays of light, like from the sun, except it was coming from the north. And so of course I got the camera and started taking pictures. So this is my front walkway. And
That
let
is
me
so
change
cool.
the picture here. Let's see if I can figure this out. It changed, right?
Mm-hmm.
Right. So some of these colors, depending on how I set the white balance, it looks different. So it's a little bit tricky. When the aurora is bright, you have a good clue of what it should look like. But if it's very faint and you're trying to enhance it, there might be some question.
Ooh.
So I stayed out until about 2:20 in the morning. I'm on Long Island. I went down to the water. I could see that there was aurora to the south of me too. And this is the comet.
Mm-hmm.
And I also went to Florida, and I decided that I would try to take some Milky Way photos. I was on Isla Morada, and I was out for about 4 hours and struggling with my equatorial mount. And then I discovered that it was set to S instead of N. So it was making all my star trails twice as bad instead of helping.
It's
So
still
this is
pretty.
a picture I took in Florida. Let's see if I can zoom in a little bit. So that's pretty much my story.
Wow.
So here you see purple and green,
Mm-hmm.
but with a different white balance, it looks pink and yellow. I could see a faint pink in the sky all night, and it kind of came and went, but it was strongest right when I stepped out the door.
That is way cool.
Yeah, so I have more photos, but that's all I set up to share.
Thank you, Stephen.
Thank
you for
you.
understanding and being quick.
No problem.
All right. Now is the time. I will turn it over to Juan Carlos,
The great. You said the great.
the Great. Juan Carlos Martinez Oliveros, the Great.
Yes. I'm pretty sure Laura is going to get bored now because we are taking out from the auroras.
That's okay. I like the sun too. It is the power from which everything comes.
Mm-hmm. So what I would like to talk to you is about a work that I have been doing on flares that is extremely related to the Megamovie, to the things that we would like to observe in the data that we are processing. And is namely Thomson scattering in the solar corona. So, you have that the sun, like a normal star, is emitting light from the surface. That light is going to be scattered in the structures that are in the corona. So in this case, you can see here a prominence, like the one that we saw in the eclipse is the same type. This one it's exploding, but kind of the same. And there are some relatively smaller ones that are called loop prominence systems. This is not new. This is well known since the 1930s. But it's really interesting because we can detect that in white light. So the work that I'm doing is mostly to report or just to show how the ejecta in white light, that is the light that we observe with our eyes or our cameras, is being, if you want, how we can use that light to assess the different parameters of these loop prominence systems, like speed, mass, volume, because all those things are unknown. So when we talk about CMEs, we said that this is a mass of gas that is moving. In reality, we don't know how much mass it is in a CME. We don't know what is the volume of the CME. And the only thing that we know is the speed at which it moves out from the sun. For this study, I was using an instrument called HMI, that is the helioseismic and magnetic imager on board SDO. So the spacecraft in here, that one is SDO. SDO has different instruments for the observation of the sun in different wavelengths. Some of them, it's in extreme ultraviolet, so you can see the helium-1 emission lines, like the orange one. Then you see one iron line that is pretty hot, that is this blue one. You can go to relatively cold wavelengths, like the yellow at the bottom. And of course, the continuum that is cold in terms of how hot the corona is. To do spectral imaging, to do the imaging, HMI has a series of filters. So it has all these different filters, these 6 filters, around one particular line that is the iron 1 line. So you take these images, reconstruct the spectra of that line. That's kind of the idea. So you're just taking snapshots of your event or the sun at different parts of your line, and then you just reconstruct it, assuming that it's a Gaussian, which is not true, but is the best that we can do. Of course, the other thing that HMI does is that it has a set of polarimeters, of polarizers. So you can get the whole Stokes vectors. That means you can reconstruct the wavefront, how the light wave propagates. So if you use HMI for one flare, that I think I use it for the September 10, 2017, what you see is this kind of stuff, these loops. So that's something that is very rare to see. You need a particular geometry to observe this. It can only be seen in the limb, when your flare is on the limb. So if we go back to the Megamovie information, we are starting our observations from the Megamovie at this particular layer. So if you have flows of mass, some of them are going to be these kind of loop structures. So from these movies, we can initially assess the mass of this material that is propagating upwards. These are not CMEs. I don't want to point that these are not CMEs. This is in between a CME and a prominence, something like that. The bubble at the top, it's hard X-rays. So we had in 2017 an instrument that could observe the sun in X-rays. It was RESI. That is the Rubén Ramati helioseismic something high energy observer, I think, imager. But you can see is that the bubble is always at the top. So I will annotate, because I can annotate, right? So this bubble, it's X-rays, and this is white light. And what you can see is that this bubble, the distance between them is always the same. It's pretty much the same. So what is telling you that? What it's telling you is that this thing is hot, and whatever is producing this material, this emission, is cold. Cold in stellar terms, of course, is like 5,000 K. So if this is cold, it's not emitting. The only possibility that you have at that moment to observe this then is scattering. So the light that comes from the surface, it can change color, I think. The basic idea is that you have the light that comes from the surface, like that, hit this structure, and then it moves in our direction. That's how a coronagraph works, right? Those instruments that allow us to observe the corona when it's not an eclipse. So we determine the intensity of that particular structure. We determine the kind of the size, and then we assume that that's a sphere, which is wrong. And based on that, we calculated the different parameters that you can observe. So these are the Stokes. It's just the polarization of your signal, the linear polarization of your signal at different stages of the flare. So it's kind of tracking these 2 times, right? A and B. The C square is the control. So if you look at the C region, it should be always being emission, because that's what the sun is emitting. And in Stokes, it should be flat. If you track the bubbles, then what you see is that they move pretty much like a CME. Okay, you see it starts very fast and then it starts decaying in the speed. It goes slower in time.
Okay, Juan, hold on.
Yes.
Okay, go back one more for just a sec.
Yes.
Okay, so people are asking kind of what we're looking at. So I was describing this is kind of a magnetic loop between a north and a south pole, kind of like what we have on Earth, but Earth has the whole the north on one side and the south on the other. But these are close. Well, they're still very far apart related to Earth's size, but close related to the sun's
Right.
size.
So
And
this
then
is here is you have a sunspot in here somewhere.
that we can't see
Here. Yes, because I occulted.
because you occulted it. Yes.
Yes. So you have the 2 loops in here. And then at one moment there was a flare. So what you start seeing is this.
And a flare is a bright light,
Yes.
a brightness that intensifies.
Right. So then you see this loopy structure, which is the same that you see here. Okay. This blooming, I don't know if you can see it, this blooming.
Yeah, is that real?
That's real-ish, meaning that that's the CCD from AIA bleeding.
The CCD bleeding. So all the photographers should know about bleeding. When do you get bleeding happening in images?
When your sensor saturates, the CCDs start bleeding in the column with the reads.
So I think people have seen that in their own photographs, probably. If you take something really bright, it bleeds in.
So
Okay.
this bleeding is typical for CCDs. You don't see that in CMOS, like a normal camera. The cameras are just clumps in the CMOS.
And what about this? So then the circle, the blob at the top.
This blob?
Yeah, that blob.
So that's the hard X-rays source.
So that was taken with a different image, a different camera.
Yeah, so this is RESI. This is HMI. These contours are HMI. This image at the back is AIA, that is the other instrument on board SDO. And again, this is just X-rays.
So you're stacking several different photographs from different cameras.
Yep.
Of one region.
Yes.
Of the side of the sun. And this looks a lot like the triangle prominence, right? From the 2024 eclipse.
Yep. This is small in scale. You see, it's only 30 arc seconds. The
Mhm.
prominence during the eclipse, it was big.
Yes, very
It
big.
was hundreds of arc seconds.
Mhm.
So if I draw the sun here, this thing was like that,
Tiny.
tiny.
Okay, so now you can go to anyone have any other questions? I just thought I would have Juan stop for a minute. Okay, and then the next slide. So now you're going to analyze all this data. That's what you're showing on this next slide, right?
So we do what usually lazy scientists like me do. That is, you take the square boxes that are in there and you average everything that is inside.
So you're averaging the pixel values.
Yeah, so that's what you get in time. So you get, this is in time. The reason why
So
it's
this
in
is the
time,
X-rays. So this is how the X-rays change over time.
this is the white light, only white
I
light.
thought the box was X-rays.
The box is on the X-rays, but this structure, see, it is
Yeah.
moving,
Is white light. Oh, and it moves into the box.
it moves into the box,
Okay, I see that now. Does
following
everyone see
the hot
that?
plasma.
Okay, so basically, so let me just take this one step. So in the first picture on the top left, there is no white light in the box. And so you would expect nothing at that time. And then
Exactly.
the next one, you see a little bit of white from the prominence entering the box. So you would expect a higher number. Okay,
Yeah.
so now we can look at your plot.
There you go.
Okay,
So
great.
this is the time. This
So
is the
here's
time of that image.
change in white light over time in that box. Great.
This is the time, 1043, 1643.
Mhm.
So that's where you see the maximum, but that structure is already in that box. In region A, that is the bottom one. Then as it goes higher in altitude, then you get that here it peaks on the region B, that is the one at the top. And in region C, that is the control, it's flat because there is nothing, right?
Yeah.
So if it was something in there, then the analysis is absolutely wrong. And physics don't work.
Because
probably
you
more
can't lose
impressive.
mass. Unless it turned into some other type of matter.
Yeah.
Or
but-
energy. It could have turned into energy. We know.
Sure.
E equals
Yeah,
MC squared.
But we should not see it in white light. So physics don't work in case that we saw something.
Right.
And that will be good for me because then I'm saying that everybody's wrong.
Right.
Right.
But what's the Stokes parameters?
The Stokes. So
Yeah,
this is a
what's that all?
polarized signal. So the idea is that you have that the sun is unpolarized. So it emits, your wavelengths go in all directions, right?
Yeah.
If you want, your vector goes in all directions. But when they scatter in one particular direction, and they will just get the polarization of that blob. So what is going to happen is that the light that is coming from the surface is going to get scattered in this direction, vertical, perpendicular to the surface. That's what Thomson's did. So what you're going to see is that the maximum of the Stokes should be in the linear polarization, which is a Stokes Q. You see a dip in there on that line.
I see the dip. And that just means that now things are scattering directly to the earth, basically.
Right. Exactly.
And then this time plot on the left is showing basically what you're saying in words and what we just saw in a plot, which is the white light feature moving away from the sun over time, but somehow disappearing, which again doesn't make sense.
Well, it disappears because the material becomes not that dense.
Right, diffuse.
Yeah, so it's the blob is getting bigger and bigger.
Mhm.
And then we don't know if this at the end it will rain back. You can have all this material and then it will fall back to the surface in something called coronal rain. Okay, so doing some mathematics that I'm not going to explain because it's late. Doing this, just solving these equations in there, just calculating the ratios between the signals. What you get is the electron density. That is this one, Ne. Ne is the electron density. You calculate it from your ratio of the polarizations. That's what it is, basically. So what we found is this, that the density is about 10 to the 12 electrons per cubic centimeter. Now, this is what I would like to see from the Megamovie. These kind of calculations, because this is new. Nobody has done it before in this way. So we can track then other stuff like doing curves and crazy things like this just to assure ourselves that the density is correct. Like, for example, we can calculate how much that particular blob is going to emit in microwaves. That's what you see, that green flux just match with our calculation. So it kind of worked, right? And I think you did all the questions already, Laura. But yeah. And that's it. Here is my the slide.
Juan, how will you use Megamovie data to answer the questions that you have?
But the Megamovie is going to give us the continuum. So this is a line, which is good and bad. It is really good because the instrument is outside and give us this particular wavelength, but it's going to be far better to use the whole continuum. I mean, all the wavelengths from, I don't know how much the camera is going to do, like 600 Armstrong to 900 Armstrong, 9,000. So we need all the spectrum to catch these things.
I see.
So if I
Brad.
paraphrase what you just said, Juan, you basically said is what this plot's showing you here is that even with all the NASA data, we can't get all the white light. It just simply
Mhm.
isn't there.
Yeah.
But you all are giving us data. You all gave us data with white light. We now have white light data of a particular event on the sun. And we will have all the, pretty much, I mean, there's some attenuation in the atmosphere, but that can be accounted for and isn't that much actually. So, because we know visible light makes it to the ground. That's why we evolved to see it.
The other thing is that the good thing about this instrument is precisely that you can see close to the surface. Okay? It's extremely close to the surface. But Eclipse data, you're seeing from the surface. And you don't need any occulter, you don't need any magic from me kind of masking stuff. It just happens naturally. So all these structures are actually going to be seen better because you don't have that bright thing in there distorting your counts.
And no bleeding into pixels either.
Well, the bleeding will happen in EUV.
No, I know, but in the Eclipse Megamovie.
Yeah, there's no bleeding.
So we
Way
just have
cool.
to get the the high dynamic range images put together, stitched together. Which we are slowly and certainly.
Steadily. Does anyone have any other questions for Juan?
Spencer?
It's a bit out of my orbit. I will say that. Pun
My,
intended.
que-
Can
my
we see that?
question, my question is, this is a snapshot, and you're getting data from this one snapshot. And you're going to take all these snapshots that we took to make the mega movie, and you're going to have a string of these graphs and things to see how the data changes. Is that correct?
Yeah, that's correct. Yeah,
Okay.
so here I'm showing you just two snapshots. But the idea is going to be reconstructing all these images. Now, you see the beginning of this? The beginning is 12 minutes, which is bad. It's really bad. If you want to see evolution of things. With the mega movie, we can use minutes or less than a minute. And
Cool.
so that all this analysis is going to be better defined.
Can we see that last screen of the takeaways?
This one? Oh,
No,
I think
the-
it
the list of
text.
the takeaways. Yeah.
Yeah, that one.
Yeah, there. I was looking at that.
We've got time for one more question, and then we will have to release Juan to his other obligations, like sleep
Right.
and family.
yeah. Nowadays, it doesn't happen. Laura knows my kid is in the laboratory.
I know, did she get into med school yet?
No, I mean the CubeSat.
Mm.
She's helping, oh, your kid is now the CubeSat, yes.
Yeah.
Cool. Well, thank you so much, Juan, for Juan
Yeah.
the Great, for coming and presenting and talking to us about your really cool, clearly breaking the world sun research. We love unanswered questions, and we love questions that we haven't thought to ask yet, which is what I think I heard a little bit of
I mean,
in
we
terms
don't
of your
know anything
research.
about
Okay,
So,
well,
yeah.
I was trying to take kind of an artsy fartsy approach to talking
Mhm.
about science. It went down in flames. So in the chat, I'm putting a message, and those are the names I have for people presenting for sure next time. Kaz will be going first because he's the one that came up with the whole idea. If you don't see your name there and you want to present next time, tell me. I will be also sending out reminders before the next meeting, which is on December 10th. And so if you'd like to respond, okay, I'll add Jerry to the list. Thank you. Thank you everyone for coming and for waiting so patiently to share, especially if you didn't get the chance to yet. I had a lot of fun looking at your pictures, and I definitely think we'll be doing more of this as we go on. Is there anything else you have to add, Laura?
The only thing I have to add is I did we have read your comments and your uploads and requests, and so every once in a while I go back to those, and I was just reminded, I know that we've had or have some teachers with us, and also of course some solar system ambassadors. And I just got back from a NASA education meeting where we shared a bunch of our resources, and there were some very nice solar education resources that I think would be really nice to go kind of demonstrate and go over here. So I think we'll probably have someone take us through some of those. Coming up.
Cool. All right. Well, unless anyone has any other questions for us, Laura or Juan, I don't know what questions I could answer, but
Was
I
there
think
any update for the NASA Helioscience team on that on the Eclipse video?
The new Megamovie or the updated
No,
Megamovie or?
No, not the Megamovie.
The video I talked about at the beginning.
Oh, sure.
Oh, the one that I missed. I think I missed it.
Is there like a release date, Laura, or?
Oh, is that what you're asking? Is there a
Yes.
release date? I think the release date is the week of AGU, which is the second week in December.
Okay.
And so I'll definitely be talking to Hannah. We'll be keeping Hannah in the loop on that, and then we will email that out.
The
as soon-
listservs, yeah.
Yeah.
Thank you.
Yeah. Thanks for asking.
Yeah, and they are, they continue, they have been showing, some of you have given a, we have been grabbing your, pictures you shared with us and allowed us to share. But if you have other ones that you wanted, or movies that you've made, or other things you think are stunning and awesome and NASA might like to share out, by all means, let Hannah know because they keep coming back to us and asking for more. So, and then they show them to all the scientists, and anyways, everyone's very happy with your amazing art and research and engineering and photography. So, in fact, I'm giving a talk to NASA on Wednesday about the project, and I was asked specifically to please come and talk about what we've done and what we're doing, and so I will be sharing all the great photos you took, or some of them at least, and the progress we're making towards getting the data set together and into FITS files, and all the Kaggle competition work we're doing, and the research Juan is working on, so, and that Troy and I are helping him with. Yeah. It's a very exciting time. But yes, keep asking if you need anything, email Hannah, Discord Hannah. She's your main connection to getting information.
There's my email if anybody needs it. I'm sure you all have it. Otherwise, you probably wouldn't be here because you probably hear about these things from the listserv. But just in case, Laura's not likely to respond because she's incredibly busy, but I'm usually in my email and not as busy. With that, I think we will call tonight to a close. Thank you so much, everyone who presented. Even though you only got 5 minutes, you did so well adapting to the time that you had and my request that you go quick. We'll have more sharing next time. And I think next month we do have another speaker lined up, someone from NASA. But if you have any ideas for share events like these, one of the themes we talked about was the Aurora. So if you have any ideas of things you want to share or things you'd like to see from your fellow volunteers, email me and we can totally get them to happen. These meetings are more for building community than they are for talking at you. So we would love to foster any kind of coming together that we can. Thank you everybody for coming, and we will see you next month.
Thank you, Juan.
Yeah, thanks, Juan. Especially